There are two systems of communication from the cockpit to the cabin. The passenger address, PA system, for passenger announcements, and the cabin interphone system to talk to a cabin attendant. In addition, there is a calls system which enables the cockpit to call the ground mechanic and the cabin crew, the ground mechanic or the cabin crew to call the cockpit. Control of all radio communications is achieved through the Radio Management Panels, RMP, and the Audio Control Panels, ACP. Let's start with the RMP. The RMPs provide tuning of all radios. There are two RMPs located on the center pedestal and an optional third one on the overhead panel. We will now look at the different controls and indications of the RMP. The on-off switch controls its power supply. The radio selection keys enable the pilot to select a radio to modify a frequency. The active window displays the active frequency. The standby window displays the standby frequency. The dual rotary knob enables the pilot to change the standby frequency, the outer knob for the megahertz and the inner knob for the decimals. And the transfer key exchanges the standby and active frequencies. The standby navigation keys provide backup navigation tuning in the event of dual FMGS failure. On the A320, any RMP can tune any communication radio, but each one is normally dedicated to a particular radio. RMP1 to VHF1, RMP2 to VHF2, RMP3 to VHF3 or HF1. The SEL, or select light, illuminates white when a pilot selects a radio on an RMP which is not dedicated to that RMP. This will be explained in more detail in the normal operation module. As we have seen, the RMPs tune the desired radio frequencies. Let's now look at the ACPs, which provide control of radio transmission and reception. There are three ACPs, each located next to an RMP, two on the center pedestal and an optional third one on the overhead panel. Let's look at the different controls of the ACP. The transmission keys enable you to select any radio or interphone system. A green light illuminates on the selected key. Only one transmission key can be selected at a time. The call light flashes amber with a buzzer when a cell call is received on the applicable radio, VHF or HF. The MEC or mechanic light flashes amber with a buzzer when a call is initiated by the ground mechanic. The ATT light flashes amber with a buzzer when a call is initiated from any flight attendant station through the cabin interphone system. The reset key silences any buzzer and extinguishes the flashing amber light associated with any of these calls. The reception knobs enable the pilot to select and adjust the volume of the following systems: communication radios, navigation aids, the interphone, the PA. When released out, the respective radio or interphone is selected, the knob illuminates white, and by rotating it, you can adjust the volume. Any number of selections can be made simultaneously. Any selected radio and/or interphone can be heard through loudspeakers. Each loudspeaker has its own separate volume control. The interphone radio, INT/RAD switch, is a 3-position switch. 2 of the positions are latched. 1 is spring-loaded. INT, latched. Neutral, latched. RAD, or radio, spring-loaded. When in the interphone position, the switch operates as a hot mic on either the boom sets or the oxygen masks. This position enables communication between cockpit crew members or between cockpit and a ground mechanic. Note, it is unnecessary to select the INT transmission key. When the switch is held in the radio position, RAD, it operates as a press-to-talk on the selected transmission channel using boom set or oxygen mask. The side stick press-to-talk switch has the same function as the radio position on the interphone radio switch. The voice key suppresses the nav-aid ident signal to enable clearer reception of the voice message. For example, ATIS transmission on a VOR frequency. The passenger address, PA, transmission key, when pressed and held, enables cabin announcements to be made from the cockpit through boom set, oxygen mask, or hand mic. PA announcements may also be made using the cockpit handset. The calls panel enables the cockpit crew to call a ground mechanic or the cabin crew. When a mechanic button is pressed, a light illuminates on the external power panel and a horn sounds to alert the ground mechanic. When either the forward or aft button is pressed, a captain call message appears at the appropriate cabin station and a high-low chime sounds in the cabin. When the emergency switch is selected on, the on light flashes white and the call light flashes amber. An emergency call message appears at all the cabin stations, and 3 high-low chimes sound through all cabin loudspeakers. If an emergency call is initiated from the cabin, the on light flashes white, the call light flashes amber, and 3 long buzzers sound in the cockpit. The ground control push button is used to energize both the flight recorder and the cockpit voice recorder on the ground. When power is first applied to the aircraft, both recorders are automatically powered for 5 minutes. Then they drop offline. The recorders automatically activate after the first engine start. Since all checklists must be taped, one item in the captain's flow is to turn the ground control switch on. The cockpit voice recorder, CVR, is used to record all the communications and oral warnings in the cockpit. PA announcements are also recorded, provided at least one PA reception knob is selected on. The last 2 hours of the recording are retained. When switched on, a blue on light appears, blue being the color for temporary operation. This light will automatically extinguish as soon as the first engine is started. This happens because the DFDR, the Digital Flight Data Recorder, will revert to auto mode and will operate continuously until 5 minutes after both engines are shut down. The CBR Erase push button enables the erasure of the tape. However, the parking brake must be set. The CVR Test push button enables the CVR to be tested. Again, the parking brake must be set to get a test signal. A DFDR, Digital Flight Data Recorder, records the last 25 hours of flight parameters. Installed in the tail section, the recorder is contained in a fire and shockproof box and is equipped with an underwater locator beacon. On the pedestal, there is a DFDR event push button, which can be used to set an event mark on the DFDR tape. If a fault occurs with the DFDR, an ECAM caution message will be generated. There are no ECAM actions for a DFDR fault. Now, let's look at the Aircraft Integrated Data System, AIDS, AIDS. To assist in aircraft maintenance, various aircraft systems are monitored by an Aircraft Integrated Data System, or AIDS. The data is automatically printed out for various flight phases by the onboard printer located on the center pedestal. If required, the pilots can press an AIDS Print push button located on the center pedestal to take an instantaneous snapshot of the various system parameters. You are in the cockpit preparation phase. As soon as electrical power is supplied, the CBR runs automatically for 5 minutes, then shuts off until first engine start. Part of the pre-flight check is to test the CBR. To make sure the CBR is powered, switch on the ground control push-button switch. Energize the CBR. The blue on light in the ground control push-button switch indicates that the CBR is powered. Once you have ensured that the parking brake is set to on, the CBR can be tested by pressing and holding the CBR test push button. Once a tone is heard, the CBR test push button can be released. The tone stops as soon as the CBR test push button is released. Note, after the first engine start, the CBR reverts to normal operation, and the blue on light extinguishes. Let's now look at a call indication from the ground crew mechanic. You hear a buzzer and notice the amber mechanic light flashing on all the ACPs. Reset the call indications. The mechanic light is automatically cancelled after 60 seconds or when the reset push button is pressed on any ACP. To talk with the ground mechanic, you have two possibilities. Normally, you select the interphone position on the interphone radio switch. But you can press the interphone transmission key, then talk using the push-to-talk switch. Select the interphone position on the interphone radio switch. This position gives you a hot mic to talk to the other pilot and the ground mechanic. You can speak in the boom set without any other selection. After talking to the ground mechanic, you should reselect the interphone radio switch to the neutral position. Select the neutral position on the interphone radio switch. In this exercise, you will be the first officer and the pilot not flying. In order to communicate with ATC, you will tune the VHF-1 radio. You can easily do so by selecting VHF-1 on RMP2. Select VHF-1 on RMP2. The select light illuminates on both RMPs. On RMP1 to indicate that VHF-1 is selected on another RMP, and on RMP2 because VHF-1 is not its dedicated radio. Now you can tune the desired frequency in the standby window on RMP2. Select the standby frequency of 126.00. Transfer the standby frequency to the active window. Observe that the active frequency changed on both RMPs. However, the standby frequency on RMP1 is unchanged. But the previous active frequency is displayed in the standby window of RMP2. This enables either pilot to change the active frequency on any radio and not change the standby frequency of the other pilot. Now let's use the ACP to establish the communication. Select the VHF1 transmission key. Select the VHF1 reception push button and adjust the volume. You are now ready for transmission and reception on VHF1. To transmit on VHF1, you can use the interphone radio switch held in radio position, the side stick push-to-talk switch, or the hand mic push-to-talk. Airborne operations are identical. The SOP is to use COM1 for all ATC communication. COM2 may be used for ATIS or for ramp communications. In the case of a hot mic, note that there is an ECAM message, but there are no ECAM actions, and no system page is displayed. The VHF1 radio is continuously transmitting. The most probable cause for this is a stuck push-to-talk switch. Therefore, check all the push-to-talk switches. You found one push-to-talk stuck in the transmit position. After you release it, the ECAM message disappears. Let's now look at another communication failure. ATC asks you to change frequency. When you look at your RMP, however, all the indications are blank. Notice the on-off switch is on. There is no ECAM caution for this abnormal. The blank displays with no lights illuminated indicate an RMP failure. Turn off RMP1. All the radio tuning must now be done using RMP2 or RMP3. Select VHF1 on RMP2. Notice that the select light is eliminated because RMP2 is being used to tune VHF1. Now let's look at another failure. You try to transmit to ATC using your side stick push-to-talk, but you receive no reply. When you check your ACP, you see that all the lights are extinguished. You try to select VHF1 for transmission, but your selection has no effect. As you were using ACP1, you can recover audio control through ACP3 by selecting the Captain 3 position on the audio switching selector located on the overhead panel. Switch to Captain 3 position. This selection de-energizes ACP1. The captain's boom set, oxygen mask, and hand mic transmission and reception functions are now controlled through ACP3. The Audio 3 transferred message appears on the engine warning display to indicate that an audio switching selection has been made.